Hello, welcome back to my channel. In today's video, we will discuss neural networks. Let's get started. Neural networks are computational models that mimic the complex functions of the human brain. The neural networks consist of interconnected nodes or neurons that process and learn from data, enabling tasks such as pattern recognition and decision making in machine learning. Introduction to neural network. Neural network is inspired by brain pattern recognition, adaptive learning. Inspired by the brain. Neural networks are computational models inspired by the structure and function of the human brain. Pattern recognition. They excel at identifying complex patterns within data, making them valuable for diverse tasks. Adaptive learning. These networks learn from data, adjusting their internal parameters to improve performance over time. Architecture and component. A neural network consists three components: input layer, hidden layers, and output layer. An input layer receives raw data such as images or text and converts it into a numerical representation. It takes raw data from various sources such as website, PDF, and PDF data from IoT devices. Hidden layers perform complex calculations on the input data, extracting meaningful features and patterns. Output layers generates prediction or classification based on the processed information from the hidden layers. Training neural networks. First, data preparation, cleaning and organizing data into training and validation sets. Here, the data preparation, we will discuss detail what is data preparation, how we can clean the data in previous video. Forward propagation, process data through the network to generate predictions. Back propagation, adjust network weights based on the difference between predictions and actual values. Neural network structure. First, nodes represent basic processing units performing calculations on input. Connections link between nodes allowing information flow and interaction. Activation function transforms node outputs, introducing non-linearity and enhance model expressiveness. Connection weights and combination function. Weights represent the strength of the connection between nodes, influencing information flow. Combination function combines weighted inputs from multiple nodes to determine the output of a node. Back propagation algorithm. There are two algorithms: error calculation and gradient descent. Error calculation measure the difference between predicted and actual values. Gradient descent adjust weights and biases to minimize the error, iteratively improving the network's accuracy. Interpreting weights in a neural network. Feature importance and pattern recognition. In feature importance, stronger weights indicate more influential features in the decision making process. And pattern recognition, weights reveal the underlying patterns and relationships learned by the network from data. Application of neural network. First, image recognition, identifying objects and scenes in images, powering self-driving cars and medical diagnosis. Natural language processing, understanding and generating human language, enabling chatbots and machine translation. Third, predictive modeling, forecasting future events, predicting customer behavior and optimizing business operations. How does neural network works? Let's understand with an example how a neural network works. Consider a neural network for email classification. The input layer takes features like email content, sender information, and subject. These input multiplied by adjusted weights pass through hidden layers. The network through training learns to recognize. These input multiplied by adjusted weights pass through hidden layers. The network through training learns to recognize patterns indicating whether an email is spam or not. The output layer with a binary activation function predicts whether the email is spam or not. Spam means 1 and or not means 0. As the network iteratively refines its weights through backpropagation, it becomes adept at distinguishing between spam and legitimate emails, showcasing the practicality of neural network in real world applications like email filtering. Challenges and future trends. The neural network is vastly used in future. Types of neural network: feed forward networks, multi-layer perception, convolutional neural network CNN, recurrent neural network, long short-term memory. We discuss this type of neural network in future videos. That's all for today's video. Thank you.